Next, we're going to look at even and odd functions. Okay, so what even and odd functions, that's just a symmetry classification specific to functions. Okay, now if we think back to that x squared plus y squared equals 25 equation, okay, that's a graph of a circle. We showed that that had all three types of symmetry. Okay, well, this graph isn't a function. Okay. So those three graphs we looked at the beginning. Y-axis symmetry, that's something symmetrical about the y-axis. Well, I can see that that's a function. So anything that's even has y-axis symmetry. So we just use our y-axis coordinate to test. Anything that's odd, that has origin symmetry. So that's like your diagonal quadrants. Okay, so you just use your negative x, negative y. So if they're asking for even and odd, they're saying we're only giving you functions to look at. So that x-axis symmetry, so this graph right here, I can see this is not a function. It doesn't pass the vertical line test. So if they're asking you to classify something as even and odd, you're only checking for either y-axis symmetry or origin symmetry. Okay, so for even and odd, it can only be one or none of them. It's not possible for it to be even and odd, because if something had y-axis symmetry, so if I have this part, then I have this part, and origin symmetry, so this part would flip over here, this part would flip over here, that would also make it have x-axis symmetry, meaning it's not a function. And even and odd is only for functions. So if we look at two examples, determine whether each function is even or odd. Okay, so again, we're going to ask you to justify these. You only have to show us the test that works. Okay, so how you determine whether it's even and odd, the process is no different than testing for symmetry. You're just only testing for y-axis symmetry or origin symmetry. Okay, so this first equation right here, we've got f of x, which is like our y, equals x to the fourth minus 2x squared plus 5. Okay, since I've got even powers of x's, I'm going to guess that I think this one is an even function. So I'm going to try even first. So remember, even is where you plug in the opposite of x and leave y the same. So I'm going to leave this part the same. And same thing, your test is going to be 2 steps. So step 1 is show us what you're plugging in. So I'm showing that everywhere I have an x, I'm plugging in a negative x, and I'm leaving the y the same. Okay. Step 2 is simplify. So any negative to an even power will become positive. So same thing here. So this is going to stay minus 2x squared plus 5. I can see that this is exactly the same as the original equation. So that means this is an even function. Okay, and you don't need to test for anything else, because if it's even, it cannot be odd. Now on this next one, okay, I'm going to try origin symmetry first. Okay, the reason I'm not going to try even is I don't think it's going to be even, because this would make a negative x here. And so I can already see that this side is going to be different. Okay, so I'm guessing that this one isn't even. If you're not sure, try the even test. Okay, but I'm going to try odd and see if that works. So I have negative y, so you're plugging in a negative x and y, equals negative x over negative x squared minus 1. So again, show us what you're plugging in. So right here, don't simplify it. Plug it in, simplify it in the next step. So a negative x squared is going to be positive x squared. Okay. And again, just like with symmetry, since this side of the equation is the opposite sign of what it originally started, it helps me if I multiply through by negative 1. Okay. So that's going to give me positive y equals, now when you're multiplying a fraction by negative 1, you're only multiplying either the top or the bottom by negative 1. And in this case, I'm going to multiply the top because I want to see if it matches the original. So I'm trying to make this go back to be a positive x. Okay, so I'm multiplying by -1 over +1. If you were to multiply top and bottom by -1, that would be like -1 over -1. That's really multiplying by 1. So you couldn't multiply this side by -1 and this side by +1. That wouldn't be keeping the equation equal. Okay, so make sure when you're multiplying a fraction by -1, it's either just the top or just the bottom that you're multiplying by -1. So that'll give me x over x squared minus 1. So this ends up being exactly the same, making this an odd function. Okay, if this hadn't have worked, okay, and the even one hadn't have worked, then we would have just said it's neither. It's not even or odd.